When we're running and debugging an application or stepping through the code, we often want to look at the contents of the memory to see the status of certain values we're interested in. winIDEA provides us with a lot of tools for dealing with specific types of memory and registers, such as the core registers window, special function registers window, and the memory window. But those windows generally offer limited formatting capabilities, and the amount of information can quickly get overwhelming. The watch window, on the other hand, functions on a bit of a higher level than just displaying raw values. It interprets and displays variables, arrays, structures, strings, and so on. It's also fully customizable so that you can display exactly the data you want, in the format you want it. You can have multiple watch windows open, and you can save and load configurations as you need them. For now, let's open a new watch window. You can do that by clicking on View, Debug, Watches, and selecting Create. You now have an empty watch window that you can configure to display the data that you want. Adding items is as easy as selecting a variable name and dragging it to the watch window. You can also drag and drop registers from the core registers window, and you can do the same for the special function register window. If you want to monitor a specific address in memory, you can double-click in an empty field and enter it manually, like this. If you now run the application, you would perhaps expect the watch items to update synchronously with the values in the memory. However, as you can see, that's not the case. The values update only when we stop the application. So, what's going on here? Well, this is actually done deliberately to reduce the load on the internal CPU bus system that the debugging infrastructure uses to read data from memory. If the memory is being read continuously, this generates a lot of load on the bus, which can interfere with the performance of your application. However, in some cases it is useful to look at how the values are updating in real time, and you can actually enable that behavior by clicking on this button here. As you can see, the values are now updating continuously. But I would just like to reiterate that this can have negative performance implications for both the debugging experience as well as for your application. If you have a small number of watch items configured, the intrusion will be essentially zero. But if you're observing arrays, structures, and memory ranges, you should be cautious when using this real-time update feature. For this reason, we generally recommend that you turn on this feature only when you need it and to turn it off once you're done using it. Now let's take a closer look at this name field here. At first glance, it appears like it only serves the purpose of displaying the variable name. However, you can actually enter any valid C expression in here and it will be parsed and evaluated. For example, you can multiply this value by 2 and the result will be displayed in the value field. You can also compare multiple variables, and the result will be 1 for true and 0 for false. You can also use array indexes. For example, you have this array here and you want to display its fourth element, so you can just write something like this. And now you're displaying just the fourth element, not the whole array. You can also cast data types. For example, if you want to cast this byte into a character, you can write it just like you would in C. While the name field can accept all standard C expressions, we extended the evaluator to also accept some additional options that are specific to the watch window. The first of which is the ability to use the printf syntax to format the value displayed here. So you can interpret this value as a floating point number, just like you would in a printf statement. In addition to all standard printf options, we also implemented our own options for some really specific cases, such as displaying 8 bytes down from the current address in a hexadecimal format. There are many more options for formatting the display, so if you need to do something specific, refer to our help page, which explains all of these options in detail. The current contents of the watch window can be saved to disk in the form of a text file. If you click on the save icon, everything in the watch window will get saved exactly as it appears right now. This is useful for quickly dumping the current values, but if you want to reuse this exact watch configuration in a different workspace, or if you want to close this window and reopen it later with the same variables and formatting, you can export the watch list. Just click on the export icon, enter a suitable name, and the configuration will be exported to the workspace folder. If you want to import the configuration, click on the import button and select the configuration that you previously saved. The watch window also has the ability to generate a Python script that writes data to memory exactly as it's configured in the watch window. This can be useful if you need to repeatedly inject specific data into your application in order to test some piece of code, for example. We already talked about this feature in our special function registers video, but we didn't mention that the same procedure applies to all watch items and is not limited to only SFRs. Here's a quick refresher on how it works. First, set the values that you want the Python script to initialize. Then select the items that you want included in the Python script. You can hold Ctrl to select multiple items. Then right-click on the selection and select Create Initialization Script. And that's really all there is to it. Let's save the script and try it out. First, we'll modify some values so that you'll see them change back to what we set them to. Now let's run the script. If you save the script to your workspace directory, you can run it from Tools, External Scripts. And, as you can see, the values got modified to what we initially set them to. So, to recap, we looked at what the watch window is and how it differs from the other memory-related windows. We saw that the values in the watch window only get updated when the target is stopped, unless we specifically enable real-time updates. We looked at various formatting and display options that the watch window offers. At the end, we showed how to quickly and easily create a Python initialization script directly from the watch window. Thank you for your attention and see you next time!